The transduction of sound starts with the external ear, and the pinna, which is pretty much the outside of the ear, is what funnels the pressure into the ear canal, and the actual pressure is what causes it hits the tympanum, and the actual pressure causes the membrane to vibrate, and those vibrations travel through the three bones in the middle ear, which are the malleus, incus, and stapes. All right, so as the mechanical waves go through the middle ear, it transfers from the stapes to the oval window, which then transfer the mechanical waves into the fluids of the cochlea, which is known as the endolith. And the cochlea contains receptors that can transduct the mechanical waves into electrical signals. And which actually occurs is that the cochlea contains the basilar membrane, which is actually the mechanical analyzer, and it runs along the length of the cochlea. So the basilar membrane actually has different mechanical properties as you travel along the cochlea. So on the outside, pretty much the biggest part of the cochlea is more rigid, thicker, and narrower. But as you travel more towards the apex, which is the center of the cochlea, it becomes floppier, and it is more broader. And the fluid endolymph within the cochlea is what actually resonates the vibrations. And depending on the frequency of the vibrations, it will move the different parts of the basilar membrane will vibrate accordingly, and that's how the transduction occurs. So transduction actually occurs in the cochlea in the organ of Corti, also known as the spiral organ, and which actually causes the transduction is that the cochlea is filled with these hair cells that, when bit, actually causes the transduction, and the inner hair cells are the primary mechanical receptors, and then the outer hair cells just fine-tune the vibrations, and the hair cells have these little extensions on called stereocilia, and that's what's actually being bit by the vibrations that causes the transduction. And when the stereocilia bit, it sends signals that causes for a rush of the endolymphs into the cells. Now, different from most cells, the depolarization occurs from the influx of sodium ions, but in this case, it's influx of potassium ions that actually cause the action potential to occur. And this transduction is what changes the mechanical waves into the actual electrical signals sent to the brain. And the vestibular cochlear cranial nerve is what actually sends the information from the ear to the brain to infer the data that it receives. All right. So after the electrical signals are sent from the ear to the brain, the signals are actually sent to the temporal lobe, which is situated right here. And within the temporal lobe is the auditory cortex. Now, the auditory cortex is located in the temporal gyrus of the temporal lobe, and the responsibility of this cortex is to process auditory signals. And after the signals are processed, they actually move to the frontal lobes of the cerebral cortex, and that's where the final sound processing system takes place, and that is how you hear things.